I'm Vandale from PCX in Belgium. Probably the only non-UK guy here. But still, I was here a number of years ago. I don't remember when. And what I will present today is what I presented then. But then I didn't show any realization, any schematics. I was just showing the product, which is still in the manual, which is here on the board. And manual, together with this presentation, I will forward to Mark and to Vlodek after the presentation, so you will get it all. In the manual, I removed all information about buying and address. My address is still there, if you like to contact me, but not the buying stuff anymore, because I'm officially not selling them anymore. If anybody is interested, we can still do some special things and provide you, because I have some boards still at home. And I also have some with me here. And I don't know if there are still raffles here, but otherwise I can give a few of them. But let's get on with it. That was a drawing made by my brother. He made frequently drawings for our magazine, and also for this one he made a drawing. It's about keyboard controlled speed up. You know, the 41, we had speed ups, we had them with switches, we had them with reed contacts and magnets and all this stuff. But this one was more reliable, and you could even switch high, low, and back without having a lockup of your calculator itself. So there was no mechanical modification needed, which was otherwise needed for this magnetic switch, where you had to adapt your battery pack, which means that you could also send your HP back to your calculator back to HP for repair, which is now also not needed anymore, because I don't think they repair still 41s. It had the advantage that when you powered on your HP, it was always in the highest speed, which you will see out of the schematics too. And you had to press 2 buttons to bring it down to a lower speed. I see people writing. You don't need it because you get the slides afterwards. So,
okay.
Yeah.
Do you use a reed switch?
No. I switch it, but I will show you the schematics. So full detail.
Okay.
There are even errors in the schematics, which I will ask you to find. I detected them yesterday evening. So by pressing two keys, you can bring it to low speed, and by pressing any key and the on key, you can get it back to high speed, or by simply switching it on and off, then it is also always in high speed. I used normally the shift switch and the on, because that didn't have any effect on the running calculations at that moment. Yeah. Like I said, you could switch up and down without the issue that your calculator was locking up. Easily to remove, and also the consumption of the full electronics didn't consume anything when the calculator was off, and when the calculator was on, it only used 1 microamp, which was very low and neglectable compared to the running use of your calculator. Normally, the installed board gave you a speed up of 2 times, but you can even go higher. And this one here, which is a half nut, I got from service in Belgium of HP. This half nut can even run without capacitor and goes to 3 times. But older machines sometimes even didn't reach the 2. And here you can see some values of the condenser that you can use to achieve a certain speed. With the installed board and the current C4 and C3, which I used, later in the schematics you will see them, which are 180 picofarad, then you achieve a 1.2 speed. So also the normal speed here is slightly higher, but that didn't give problems for the card reader or any other equipment, which was the case if you really run at 1.8 or 2, then card reader was not working anymore. HPCC was working, but probably the wand was also not working. I'm not sure, because I didn't test that in detail. This is the first schematic I made. So what you see here is a flip-flop, in fact, and then an HEF66, 4066, which is in fact an analog switch, a CMOS switch. And I use them in both directions, so I used 2 of them, reversed, to be sure that everything was working, then put 2 condensers in series, and as such, then the original condenser here is the C5 or the C star, which is in the documentation mentioned. There's a C3 and C4. When you press the on button, that's what you see here at the bottom, then through this capacitor you generate a clock on the flip-flop which is loading a 1 as a data. That means that Q becomes 1 and Q not becomes 0. That means that the switches are open, and in other words, you run at high speed. That's the reason if you switch the calculator on, you always end up at the highest speed. When you press the two other buttons here, the multiply and the minus, but you will see on this version, and I hear that back from some other people too, that on some calculators it is the minus and the divide button that you have to press. Don't ask me why, I never searched for it. But also here it can be a miswiring on this one, but it can also be that there is a difference in the boards, a slight difference which results in this effect. When you press this, then you generate a reset. A reset is loading a 0 on the Q port and on the Q not and 1. And this one is driving these two CMOS switches in on state, which is putting these two condensers and series and parallel on the 33, which is here at the bottom. And as a result, you get the normal lower speed. Like I said, in this drawing, but perhaps there are not electronic guys and you are rather far from the screen. I don't know if you can see, but there is a big error in it. And the error relies with these guys and this guy, which are not 33 nanofarad, because then the HP would be running very slow. It must be 330 picofarad and not nanofarad. That's on this one. And even these ones we lowered later. We lowered them. So this was the initial schematics using a flip-flop and an CMOS switch. Then I made them and have them also with me, the first samples. I made them on simple paper to make them thin enough with normal components. I don't think that this guys still work, but okay. But it was on paper, cardboard. It were in fact Pons cards from computers, which I used. And then I made the first PCB version, which is here. I also have it with me. And then later the first SMD version, which I also have here. So on the bottom one you see clearly, on the bottom one, come on, help me, yeah. Bottom one you see clearly the flip-flop here and then the switch. However, that schematic was not 100% fail-safe. I had still issues with it. So later I made, here that's the integration I made on the calculator itself, on an older one. And I also had at that moment adhesive labels which you can glue on top of the other one, and that was even printed with the old HPEL plotter of HP together with the 41. Then I made a new drawing, a lot less nice. I never made a decent drawing of it. And the initial difference here was that it was full CMOS. The other one was also CMOS because I used a 74 HC74, which was also CMOS. But here I put some extra buffers at the entrance. And on the schematics here, you see a 7401, which cannot be used because that's an AND port. That's an AND port, yes, but that means an AND. That means that if you press one of the keys, it will already be going to low speed. So that was wrong. So that was initially changed into a 4001, which is a NOR port. And there, of course, you need to have, the logic table is here below, you need to have the two keys pressed to have a high at the output. Because the scanning, that's perhaps not clear from that schematic here, the keyboard scanning of the HP is generating negative pulses. So if you have a pressed key, it's a negative pulse. So also here the negative pulses came in, and I got rid of the diodes, I got rid of the extra resistors, and that made the schematic a lot easier and simpler to make, and resulting in this board. Here the initial drawing I made. And if I then go to the next slide, you see the initial boards, of which I have also samples with me. Initially, it was on a thick normal PCB, even fully normal. I don't have that one with me, but okay. So normal PCBs, and then I also added the extra layer, the green layer, to make the soldering a bit easier. And because at that moment I was for sure not experienced in SFD soldering. But okay, we got it working. And finally, we also did go to thin PCBs to make it even easier to put it in the 41. These are the layouts if you like to make them yourself. They are, of course, at a bigger size, size 4/1. They have to be reduced. These were all the boards on which you could install them. At that moment, I'm talking about many years back. I think early 2000s, something like that. 2000. A bit later, the half nut was already out, but the full nut was not yet out. So I don't have drawings of the full nut, but I think the full nut was more or less identical to the half nut, with the only exception that the top was different. But I don't know. That one I don't have drawings of. And I also made that time my own jig to test out the PCBs. There is one here, and normally it should work. So if I run here, yeah, I should put it closer to the speaker now. You hear the high speed, and if I press 2 buttons, then it goes to low speed. You can test it, and any board can be put below here to test it out when it is manufactured and manually soldered by me. Then some measurements I did on the power it was using. So a bit not weird, but in all measurements that we executed, I saw that lower voltages resulted in a reduced sleep and standby mode with respect to current, but was increasing the current in run mode. And you can see that out of the figures here below also. Yeah. And next to it is the explanation of the operation mode here on the right side, and the second column here is the one where the turbo is installed. So on the normal consumptions, you don't see any different. Even in sleep, you don't see any different. Probably it had to be 61 microamp here, but I only measured 60, so I cannot lie at that moment. These measurements were still done with the old board, so not with the new CMOS board. But the new CMOS board was even consuming less. So, and that's it from my side. So quite short. Catch up on the agenda. I still have, if time is left, yesterday from my Daikin colleagues, I bought here 2 years ago an RPN calculator, an Anita, and have it with me, so then I can also switch it on. It works. I tested it yesterday on my hotel room. But that was not, I normally didn't bring it to here, but it is here, so I can still show it if people are interested. It will be easier. Yeah. You can test it while you are here. So it's not an HP.
Is that a nixie display on it?
It's a nixie display, yeah. I find it a nice thing to put on my desk. Still RPN, not HP, but okay. But pure legacy.
Just twist it round this way.
Oh, we can see the numbers from here.
Yeah, it's a nice thing to put on a desk. I bought it from a guy here in the UK, and he was not willing to send it to Europe 2 years ago already. So at that moment, I was still working for Daikin. So I asked one of the Daikin guys, "Can I give your address?" And he said yes. And it took 2 years to get in my hands because they were always giving it from one to the other and saying, "Yeah, perhaps next week it will be in Belgium," but it never arrived there. And so last week I said, "Guys, I'm now coming to the UK. Can you make sure that I can collect my package?" So yesterday I was in the offices of Daikin here in London, and I could collect it. So, and it's working, which is nice, of course. And I was a little bit afraid that it would be 110 volts only, but that's even going to 240 and even 250, it says on the bottom plate. So That's it. Thank you.
Thank you very much.